All right, let's talk about the periodic table. Okay, so the things we're going to hit in this video, we're going to look at groups, families, and periods, just different ways to group things in the periodic table. Uh, some of the groups in the table have important names, and people refer to them with those names, use the names very often, so you should know what those are. We're going to talk about those important groups. You should be able to tell where different kinds of elements are in the periodic table, in particular metals, nonmetals, and metalloids, because those have very, very different properties. At least metals and nonmetals have very different properties. Metalloids, of course, are sort of in between the two. So you should be able to identify metals and nonmetals just by looking at the periodic table. And we also want to break the table up into another couple of groups, main group elements and transition metals, because again, those are terms that people use very often to identify different parts of the table. All right, so the first thing is, you've probably heard of the periodic table, when you were in elementary school, or if not middle school at least, and you've heard that name many, many, many times. But did you ever ask yourself why it's called the periodic table? Or for that matter, what does periodic mean anyway? Right? So periodic in this case refers to the same kind of a phenomenon as we had in math, where we talk about periodic functions like sine and cosine. So like a sine function look like that, and a cosine function. Um, let's see, cosine starts at 1, right? So cosine function. I'm not sure if I have that right. I think that's right. Anyway, they're offset by 90 degrees. But anyway, so periodic means a function that repeats itself over and over again, right? And the periodic table does the same thing. People started to realize in the middle of the 19th century that if you look at certain properties of the atoms and then you line them all up in order of atomic mass, people didn't know anything about protons at the time because this was, 50, 60 years before protons were discovered. But they still could they could calculate the masses of the different elements. And they found that if you made a graph, you put the mass on one axis and you put some kind of a property on the other axis, like density or something like that, you would get periodic functions. So for example, this is a graph of atomic radii. Of course, they couldn't measure radii back in the 19th century, but you can see that the radii of the atoms starts small at hydrogen, goes up to lithium, then kind of drops back down to fluorine, then goes up to sodium, then drops back down to chlorine, then up, so on and so forth, right? And it repeats over and over again. And you'll notice in here, if you look closely, that there are a couple of spots here where the properties don't change very much, right? So there are these little flat parts that are kind of stuck into the middle, and I'll show you where those are in the periodic table in a little bit. These flat parts are important and make an important distinction between the parts that have the really nice periodic function and then these little intervening flat parts in here. Anyway, so you can do this with ionic radius or ionization energy or density or a whole bunch of different properties, and you always get the same kind of periodic function. Right? So in the mid 19th century, Mendeleev was looking at this and decided that he was going to um, see if he could find some way to kind of organize this idea, and he came up with the very first periodic table, which is shown over here. This was in 1869. In fact, last year was the 150th anniversary of the periodic table, which is kind of exciting and wonderful. Right? Uh, his was organized a little bit differently. His his columns are our rows and our rows are his columns, but the same basic idea is in his table here. And there's also something really important. This is probably too small for you to see in this image, But there were a couple places where he mapped out the properties of the elements, and there was no element that had the property that he was expecting, right? And this is one right here, for example. He was looking at how that periodic function goes, and he said there should be an element with a mass of about 45 that fits this property, and he couldn't find one. So instead of just skipping it, he put a little space in his periodic table and said, we don't know what it is yet, but there's going to be an element here with that property. And so he predicted the existence of elements that hadn't even been seen before. And not only did he predict that they would exist, but he predicted some of their properties before they'd ever even been seen. In fact, one of these was gallium, and gallium has the name gallium for France because it was discovered by someone in France. I don't remember when this was. It was late 19th century, and Mendeleev was still alive. The person who discovered gallium did some measurements and published the density of gallium, and Mendeleev looked at it and said, no, that's not right. It should be a little different, and sent a letter to the guy in France who discovered it, and he rechecked it and said, oh yeah, you're right, I made a mistake, and they revised the density. So using this idea of periodic functions, the properties going up and down in a predictable pattern, Mendeleev was able to predict the properties of this new metal gallium, which he had never even seen before, and he was able to predict the properties of it better than the person who discovered it and had a sample of it in his very own lab. All right, so there are a bunch of different kind of organizational schemes in the periodic table, and the first one is periods and groups, right? And the periods, you read it across this way. Right. The periods are the rows in the periodic table. And I should mention, I kind of alluded to this before, but and you can tell if you look at the table, they're now organized in terms of atomic number. So if you look at the periodic table, you'll see this is atomic number 1, hydrogen, atomic number 2, helium, atomic number 3, 4, 5, 6, 7, so on and so forth, all the way across the whole table. So they're arranged in order of atomic number, which of course is the number of protons in each atom. Right? Okay, and so the rows are called periods. So hydrogen and helium make up the first period. Lithium, beryllium, boron, all the way up through neon make up the second period. Sodium begins the third period, and so on and so forth. Right? The columns are called groups, right? And so this over here in this column here, this is group 1, this is group 2, and so on and so forth. The groups are really more important usually than the periods, because elements that are in the same group, especially on the far left-hand side and the far right-hand side, this is a little bit less true in the middle of the table, but on the far left and the far right, everything in the same group has very similar chemical properties. So everything in group 1 behaves in a way that's very similar to everything else in group 1. Everything in group 2 behaves in a way that's very similar. Everything in group 5 here has similar chemical properties. And everything in group 7, and so on and so forth. I guess I should say something. I was going to do it somewhere else, but in case I forget, the numbering system for these groups has changed over time, and the ones in the middle used to be omitted, and so we would call this group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. Right? More recently, IUPAC, which is the governing body for chemistry. It's the International Union of Pure and Applied Chemists. They set all the rules. Maybe about 20 or 30 years ago, they said that we should include all of these, and so they set a new numbering system where they said this is going to be group 1, this is group 2, this is group 3, group 4, group 5, so on and so forth. Zinc would be in group 12, and boron would be group 13, carbon group 14, nitrogen 15, and that last column on the right would be group 18. Right? So most periodic tables are labeled that way, but a lot of people, including me, right? A lot of people still use the old numbering system, and so people will usually still refer to boron as group 3, carbon as group 4, nitrogen as group 5, oxygen 6, fluorine 7, and these guys on the far right as group 8, right? So this can be called, boron group can be called group 3 or group 13. The carbon group can be group 4 or 14. Right? You'll hear it both ways. All right. Now, because the guys in the same column or the same groups have similar chemistry, we talk about them together. And so some of these things have special names described by their chemistry. So group 1, for example, over here, right? These are called the alkali metals. Group 1. Alkali metals. And that's an important name, right? When people are talking about them, they will say the alkali metals, and so it's important that you understand what people are talking about when they use that term. I'll make a little correction on this graphic here, though. The top of this block up here on the top of the group 1 is hydrogen. Hydrogen is a group 1 element, but it's not considered an alkali metal because it's not a metal. So alkali metals really more accurately refers to all of those below hydrogen, right? Lithium down through francium. All right, the second group, group 2 here. Group 2. These have a very similar name. These are called the alkaline earth metals. Okay. That's also important for you to know. Okay. Then I'm going to skip over here to group 7 or group 17, whichever you want to call it. Group 7. These are called the halogens, right? And halo is a Greek prefix meaning salt. So halogens means salt producers. And the reason they have that name is because a lot of compounds, ionic compounds in particular, that include guys from this group have make compounds that are very similar to salt, right? They have small cubic crystals, they dissolve in water, behave very much like typical sodium chloride. All right, group 8 over here on the far right. 8. Okay. These are all gases, and they're very unreactive. And because they're unreactive, they're hard to see, right? Because they're invisible, of course, right? And the only way you can detect them is when you do some kind of a reaction or something like that. And since they don't react with much, they're hard to see. So people thought that there were not very many of those around. And so when they were initially discovered, they were called the rare gases. As people began working on them more, they found they're actually not all that rare. In fact, argon, this one right here, the third one down, argon is actually 1% of the atmosphere. So they decided they aren't really all that rare, so rare gases is not a good word for them. And so they changed the name to the inert gases. And then in the 1960s, a chemist started working with group 8 compounds and reacting them with other very, very reactive compounds. And he was actually able to get them to undergo a few reactions. Not a lot, but a few. And so they decided that since they do react with things, they ought not call them inert gases because they're not really completely inert. And so they changed the name to the noble gases. And noble, in this case, they use this word in chemistry a lot. Noble in this case kind of means like, they think they're better than everyone else. They don't associate with other atoms. They kind of keep to themselves. So noble in that sense kind of means something similar to inert. All right, they don't react with other things. All right, now these 4 groups are really important. So you should know group 1 is the alkali metals. Group 2 are the alkaline earth metals. Group 7 are the halogens, and group 8 are the noble gases. Those are really important. Now, some of the other ones also have, some of the other groups also have names, but the names aren't used as often. So this purple one here, group 6, for example, I'll use blue for that. Group 6 here. These are called the chalcogens. And just like halogen means salt producer, calc is a prefix meaning chalk. And so the group 6 elements are called the chalk producers because when you make a compound with group 6 elements, they often come out kind of powdery and chalky. And so this group here is sometimes called the chalcogens. But this name is not really used nearly as often as the other 4. So those other 4 you really, really need to know. Group 6 chalcogens, I'm really just kind of throwing that in there because it's fun, and we're all here to have fun, right? But you don't need to know that one. It doesn't come up that often. Okay. All right, we can also talk about regions of the periodic table, and this is important. We can break the main body of the table, the top part up here, into 2 parts, and that is the main group elements, which are on the left and the right, and the transition metals, which are here in the middle. And if you remember, going back to that graph of ionic radii, we had something that looked like this, right? And every once in a while there was a little spot in there where the properties didn't change very much, right? The part where the properties don't change very much is this group right in here, these transition metals, right? So you see really good periodic behavior if you look at the elements on the left and the right, and you get kind of a, I don't know if a dead zone is really the right word, but you get a period in the middle where you've got a bunch of elements where the properties don't change nearly as much as they do on the left and the right. Okay. So for that reason, particularly if you're looking at trends and behavior of atoms and stuff, these guys over here on the left, groups 1 and 2, and these guys over here on the right, groups 3 through 8, those are called the main group elements, and these here in the middle are called the transition elements or the transition metals because they're all metals. Now down below the table, there are 2 more groups. These are sometimes called, I don't use this term, but as a group, this whole set here, both rows are sometimes called the inner transition metals. But more commonly, this first row are called the lanthanides, and the second row are called the actinides. And those are easy to remember because they're just named after the first element in each of those rows. Right. So this first row here. Those are the lanthanides in this second row down here. Those are the actinides, right? So, 4 groups you should know: lanthanides, actinides, the main group metals, and the transition metals. Or excuse me, the main group elements and the transition metals, because these main group are not all metals. All right. We can also divide the periodic table up into blocks. You can kind of see a block structure even without the colors here. And people will sometimes refer to them as the S block elements over here, and the P block elements over here, and the D block elements here, and the F block elements down here. And those terms, S, P, D, and F, will make more sense once we get into electronic structure. You'll see where those terms come from. I probably won't use those terms very often until we get to that point, but I just wanted to kind of throw that up there as kind of a something to look forward to, and to see that coming up. All right, now one of the biggest and broadest dichotomies in the periodic table, way we can classify things, is with by describing things as metals or nonmetals. And everything over here on the left side of the table, all this stuff over here, including the lanthanides and actinides, right? These are all metals, right? And that means they're going to be fairly hard, shiny, probably have fairly good electrical conductivity and thermal conductivity. You can bang them with a hammer to reshape them. You can do all those kinds of things, right? Almost all of them look kind of the same. They look kind of silvery. Copper and gold, of course, look a little bit different, but all the other ones look very similar. And as far as physical properties go, they all are very, very similar in their appearance, right? So these are all the metals. On the far right-hand side, these are all the nonmetals, right? And nonmetals include things that you would recognize as nonmetals, right? Like nitrogen, you know that's a nonmetal, that's a gas, and oxygen, right? And chlorine and sulfur. You know, sulfur is kind of a yellow powdery substance. Right? So these all have properties that are very, very different than the metals on the left-hand side of the table. Okay. And let me mention again, hydrogen's a pain in the neck because hydrogen just defies all logic, right? Hydrogen sits over here on the left side, but hydrogen, of course, is not a metal. Hydrogen is also a non-metal, even though it's on the left side. Some periodic tables actually put hydrogen here because it really defies all the different classifications. Some periodic tables put hydrogen here, but then put hydrogen again over here because hydrogen in a lot of ways behaves similarly to these to the halogens over here. All right, so we've got the metals on the left side, we've got non-metals on the right-hand side. The properties are very different. You know, these guys are all hard and shiny and conduct electricity. Everything over here on the right side, a lot of these are gases. One of them is a liquid. Bromine here is a liquid. The ones that are solids are kind of crumbly and powdery, very, very different than the metals. And right in between, we have a group that have intermediate properties, because if you think about the periodic properties, things are gradually changing as you move across one of these periods from the metals to the non-metals. You have to have kind of a transition in between somewhere. And so that transition is this group right here called the metalloids, or sometimes called the semi-metals, right? Which basically just means they act kind of like metals, but a little bit different. They just have intermediate properties between metals and non-metals. And if you look at most periodic tables, a lot of them will have kind of a red stair-step line here. Not all the tables have it. Most of them do. I think all of them should. I think it's important. but most of them will have a little red line that goes like that. And all of the metalloids are the things that are just sitting on top of that line, right? Plus two other ones below the line, germanium and antimony. Right? All right, so you should know these guys. In fact, just by looking at the table, you should be able to classify anything as a metal, non-metal, or a metalloid. And so you just have to remember metals are on the left, non-metals are on the right, and be able to find these metalloids here by looking at this red stair-step line. Or you can just remember they start with boron. Right? Start with boron and then go down diagonally. That's where the metalloids are. All right, so in looking at the periodic table, we talked a little about the history because it's fascinating and fun. But mostly we talked about groups and families and periods. The periods, excuse me, I started to write that the wrong way. I was thinking about one thing and saying something else. The periods are the rows in the periodic table, right? So each horizontal row is a period, and each column is a group. The groups are sometimes called families. I think most people call them groups. That's much more common, but sometimes they're called families, right? And all of the elements in a group have fairly similar chemical properties. And so that's why the group names are really useful. Alkali metals and alkaline earth metals and so on and so forth. Okay. And we talked about names of important groups, like the ones I just mentioned on the left side, and also the halogens and noble gases on the right-hand side. You should be familiar with all of those group names. We talked about the broad classification of all of the elements into metals or nonmetals, with a few that have intermediate properties between the metals and nonmetals. Those are called the semi-metals or metalloids, and they start with boron and go down diagonally. And again, like I said, most periodic tables will include this little stair-step line in the table to help you identify where the metalloids are. And then we also looked at naming different regions of the table, the main group and the transition metals, and then also at the bottom the lanthanides and actinides down at the bottom of the table. All right, terrific. Read through that section in the textbook, whichever textbook you're using. Take a look at that. There'll definitely be a good description of all those different groups and families and properties of the periodic table. So please read through that and work through the study guide. All right, thank you, everybody.